Okay, I'm recording, sorry. Okay, so what I'd like you to do is to work out what is formed in each one of these here, and also name it. So just have a moment having a look at that, see if you can write. Can you see it okay? Is it okay? Have a go at writing those.
What's on the back of your shirt, Stanley?
On the back of my shirt? I can't remember. Some nonsense. It's a TK Maxx special.
Okay, I thought it was a Kingswood shirt.
No, mate. No. We don't wear anything this common and coarse.
But isn't Kingswood colours navy and white?
No, they're sort of red and what are they? Red and white. Yeah. They're yeah. Of course, there aren't any colours at the moment because we're not allowed to play any matches.
Yes.
Not allowed to hug each other. Oh, Sophia has disappeared and come back in. Sorry, Sophia. What's 55,000 Kenyan shillings, Yestin? Sorry, Sophia, I didn't see you there waiting.
55,000 is £400-ish.
So 50,000.
55,000 is £400. Yeah.
400 quid? You're joking?
I think. So. Have I got that right?
No, I'm sure you have. It's just I asked. I was asking Sophia this morning how much for for a loo, for a toilet, for a 2-door toilet, hand washing station, and the difficulty is connection to the sewer, of course.
Yes. Depends.
Can't believe it. The whole of Kibera doesn't have attachment to the sewer line. That's just. How do they expect people to live?
Informal slum settlement.
Yes.
Government doesn't have to take responsibility.
I know. Right, students, are we done? Done?
Yes. You had a thumbs up from Tuscany.
Okay. Do you want to show me on your sheet? Just show me your page. I should be able to see what you've written. You're showing yourself at the moment, Fatma, which is very nice, but it doesn't tell me the answers. Yes, very good. 10 out of 10. A grade, 100%. Very good. Did everybody get that? Was everybody okay on that? Okay, so now I'm going to do the making soaps from fats. Okay. So an oil or a fat is only the only difference between oil and fat is solid or liquid. Oils are liquid and fats are solid, that's it. They're all the same structure. The structure is, there is a 3-carbon unit which comes from glycerol. And glycerol is an alcohol. I'll just change this, I'll do it the other way around, because then it'll be like what we just did. So here it is a 3-carbon, so it's prop, and it has 3 OHs on it. So this is glycerol. These are hydrogens. So this is glycerol. And glycerol in nature joins to fatty acids. And the fatty acids are very long chain. And I'm just going to show a long chain like this. And then they have an acid on the end. So the acid is an OH here. And this joins on to make the ester. So we have a long chain, a long chain, a long chain. Sometimes these have lots of double bonds in them. This makes them polyunsaturated. You know the word unsaturated just means that we have alkene. It has many double bonds on the chain. Some oils have many double bonds. For instance, corn oil doesn't have many double bonds, but some others like rapeseed oil has many double bonds. So this is the fat or oil, okay? And when we react it with sodium hydroxide, normally sodium hydroxide, this is a hydrolyzing agent. So we get hydrolysis. And in hydrolysis, you remember that the acid and alcohol is a reversible process to make the ester and the water. What the sodium hydroxide does is to put the water back into the ester and turn it back into the acid and the alcohol. But because it's in alkaline conditions, the acid is neutralized, so the sodium hydroxide makes this into a salt. So what happens is that this ester here breaks here. This is the ester bond, this bit here, okay? It's the same in simple esters, in polyesters, in soaps. So what happens is that it breaks, and it breaks the glycerol off, like this, and then we have O minus Na plus, O minus Na plus, O minus Na plus. So out of the one oil or fat molecule, we now get 3 salts of alkanoic acids, okay? So this would be called, let's say we start with a palm oil. So this would be then sodium palmate. Whoops. This is the sodium salt of the acid which comes from the oil. So this is a basic soap. Actually, the glycerol is a very smooth liquid, and some of it is added to the soap to make it nicer, you know, so it's smoother. But the basic salt makes the soap. So that's the soap. So what we generally do is we have to write an equation like this, only it's reversed now. So we have the oil, which is, or the fat, doesn't matter which one it is, and NaOH, alkali, and we have to heat it up. We need to heat it up because otherwise it doesn't react properly. Sorry, is that in focus? Yes. And what it forms is the sodium salt of the acid. So it forms the salt, and it produces the glycerol. Now, I haven't seen the need for you to write the formula of glycerol. I haven't seen that in a question, but I'll just show you it. So it's because it is easy. So the glycerol, if you remember, was attached here. Okay, and it's an alcohol, and it's a 3-carbon. That's why there are 3. We call these fatty acids. Fatty alkanoic acids, you probably know that. So these fatty acids are joined onto a 3, because there are 3 of them, there has to be a 3-carbon chain here. And that 3-carbon chain is 1, 2, 3. Each one has an OH on it. I'm not going to bother with the other hydrogens. I'm just going to do that. You don't do this in an exam, but it's okay in your notes. This here will be called prop, and it should be called propanol, but it's called propan triol, meaning 3 ols, 3 alcohols. It's sometimes called propan or 1, 2, 3 propan, which tells me it's on carbon 1, 2, and 3 like that. Okay? So that's glycerol, propan 1, 2, 3 triol or 1, 2, 3 propan triol. Okay? Another question. Has anybody got another question? I can go back. We have a set of chemicals. I'd like you to tell me how they're made, but if you have any other problems, we can go through that just now. Any other problems? Are you okay? If I just go back to the share thing, just for a minute. If I go back to the share screen, if I go back to this, just for a moment, are there any of these stages, 1, 2, 3, 4, 5, etc.? Are there any of these stages which you're not sure about? So don't do them necessarily in order, but just if you have a look, okay, can I do that? When you're looking at something like this, you actually have to try and remember the chemicals, okay? So you have to think, oh, yeah, okay. What chemicals are needed and what do I have to do to it? So see if there are any there. I'll come back and stop sharing in just a minute, but you can tell me if there are any there which you're not sure about. This, if you can learn something like this, it will become visual for you. You will be able, in an examination, to imagine this sheet, and then any of these reactions which come up are really quite easy. So just have a quick look. 1, 2, 3, 4, 5, etc., etc. Just have a look. Okay, were there any which make you go, Were there any which were difficult at all? Number 1. Was number 1 okay? Let's just, were there any, number 2, 3, 4, 5, any of those were problematic at all? Because otherwise we're going to go and we're going to try see if we can work out how to do some changes. No problems? All okay? Everybody okay?
Conditions for polymer and how to draw it.
Sorry, say that again. The conditions for polymer?
Yeah, from alkene to polymer.
Okay, yes.
And then to draw the structure.
Sorry, from alkene to polymer, the conditions for actually making it?
Yeah, and then how to draw the structure.
Okay, sure. No problem. I'm going to start with the structure because that's the most important. It goes like this. This is an addition polymer. This is an addition. You need to turn your mic down a bit. Thank you. Okay, so in the kind of polymerization I had on that sheet, because there are 2 kinds of polymerization, as you know. So this is addition polymerization, and this, you know, comes to this. And sometimes we're asked for 2 units, but we generally draw it like this, which says it continues. Okay, it just goes on and on. So if I start with a number of these, let's say n of these, then n goes down here. If they ask you to draw 2 bits of it, then you just go, okay, there's the first one, here's the second one, and that's it, okay? That's the structure of the polymer. Now, when you get polymer questions, quite often they draw you a bit of polymer and they say, what was the monomer? What was it made from? So this is how it goes. I'm going to draw some and I'll show you how it works. So the idea is, whatever the structure is, it will be like this, but these may be different. Okay, so I can change just one of them. Let's say I want to make PVC. PVC for coating electrical cables or clothing that it looks like leather, feels like leather, but it's not leather. I put 1 chlorine on. And then there is 1 chlorine here. That means that every second we'll have a chlorine on. So not this one, that one, not this one, that one. So this would be the polymer from this monomer. And that helps you see how to do it, because I'm going to draw some now. So I'm going to, this would actually be called a vinyl chloride or chloroethene. So this is PVC, polyvinyl chloride here. But I'm going to draw some polymers and see if you can work out what we have here. And then we'll look in the conditions for actually making it. So if I have a little bit of polymer, I'm not going to tell you how many there are. There's one. Okay, so what we have to do with these are 2 sections of polymers. This one is called polypropene, and I'll show you why. This one is polystyrene, and I'll show you why. What you have to do is look for the repeating unit. So I just start on any carbon, but I have to remember which one I start on. So I'm going to start here. And what I'm going to do is I'm going to go along until I find the same carbon again. So I'm going to go carbon, carbon, now that one is exactly the same as this one. Do you see that? So I start here and I go, there's a CH3 attached here. This is different, that's the same. So this was the monomer. So all I have to do is to say, okay, it wasn't attached here, and it was a double bond here. That's it. That simple. So I start, it doesn't matter where I start, it's the same every time. So let's say on this one, I'm going to start here. So I'm starting in a different place. It doesn't matter. So I start here, I look at this, I have 2 hydrogens. Then I go on, I have a hydrogen and whatever this thing is, C6H5. I hope that you know that's benzene. Then I go on, this one is the same as this one. Do you see? Carbon with 2 hydrogens, carbon with 2 hydrogens. So this, there, get rid of these, that's the double bond. That was the monomer. That's how you do it. That's how you undo it, okay? Now the conditions depends a little bit on what kind of polymer you're going to make. But in general, it goes like this. So is everybody happy with that? Is that okay? Yeah, okay. All right. So we're just trying, in each one of these, we're just trying to find, in the chain, we're trying to find the repeat unit, okay? The most difficult one that you get is this one, because if they say, draw the repeat unit using propene, what many students do is they go, okay, this is propene. I must join this and here. And this doesn't join. So every time you get something like this, you just redraw it like this. So I go, okay, there's the double bond. On this carbon, I have 2 hydrogens. On this carbon, I have 1 hydrogen here, and also this. And that's what I start with, because then it's easy. Okay, conditions. There are 3 conditions. When you start with a monomer, the monomer is a gas normally. Because it is a gas, we have to push the molecules together so they can group, so they can get to each other. So the pressure, it depends on the type of polymer you're trying to make. For instance, polythene, the polymer made from ethene, if you want it to be high density, that is a very strong polymer, then you have it low pressure because you want it to make long chains. If you put it under high pressure, it makes very branched chains, and that's the stuff which Kenya has got rid of in plastic bags. Low density polymer is plastic bags. It's not very good. So the pressure is sometimes it's up to 2,000 atmospheres. Up to 2,000 atmospheres. But, and you would, you need to check your specification just to check which one you are asked to do, because I couldn't find in the specification which one they wanted you to do. But it's about 20 atmospheres up to 2,000, depending on the polymer. The heat is normally not too much. It's normally around about 100 degrees Celsius. The catalyst, sometimes it's a metal catalyst or what we call an initiator. And the initiator is often a peroxide. A peroxide starts a free radical reaction. In other words, what it does is it breaks part of the original monomer, and when it breaks it, it allows it to go crazy. It allows the reaction to become a chain reaction. So the catalyst is often something really, these are very dangerous, very hazardous. If you work in a plastics factory, something like benzoyl chloride or something like that, this stuff here is very hazardous. But because it starts reactions in anything. So it makes a free radical reaction, which starts it breaks one molecule, and then that attacks another one, and so on. So it makes a chain reaction, so it makes it really long. If you have very high pressures, this makes short, branched chains. Low pressure makes long, unbranched chains. These ones here, the long ones, are high density. High density is very, very strong. Low density, rubbish. Very, very cheap. Very, very quick to make. Push it together, makes it branched and so on, but they're rubbish plastics. Morning. Okay. Any other questions? Sorry, can you see that? Okay. Any other questions? No? Right, good. Here we go. Okay, here we go. So let's see. Okay, here's a little thing that I want you to try and do. I want you to see whether you can very quickly tell me how to turn propene into propanol, ethene into ethane, ethanol into ethanoic, etc. Okay, let's see if we can do those. So this is a little check to make sure. So try to do it without looking at your notes first. It's not a test, but if you just try to do it without looking it up, then you will know whether you understand and have knowledge of this organic chemistry. Okay, so you just start with any one and you go, okay, propene to propanol. How do I do that? Because if you can do it really easily, then you are okay. If you find you can't do it easily, then you are making a mistake, which I will explain in just a moment. Okay, so just have a few moments to look at those, please. See if you can do those. I'll be asking you to do them.
It's actually got Scotland on the back, Sally.
Oh yes. Well, I was born there.
I seem to remember that.
Really? I've supported them a bit over the years, just because I really love an underdog. And they often are.
Yes. But always seem to come up with something when they're playing England.
Oh yes. so does just about everybody, don't they? It's just one of those things you just go, oh God, here come anybody against us.
Yeah.
So you're right, you're healthy?
Yes, yeah. Sophia, are you listening?
Yeah.
No, I was asking Sophia.
Oh, Sophia. Oh yeah, go on.
Are you listening, Sophia?
Go for it, mate.
Yeah, no, we're in the process of making an application, which is really very, very exciting.
Really?
Yeah. Sophia?
Yes, I'm here.
I read the proposal. It's very exciting. I now understand your excitement.
I hope that side. Mark, we might get support from International Organization for Migration.
Really?
To support refugee children that are in the slums.
Oh my gosh.
Yeah, but we just started the discussions. So we hope.
Okay, I won't say anything, but what a wonderful, wonderful idea.
Yes, it's very exciting.
It's better than exciting. It'd be a way out.
Yes.
And this is for a substantial number of children as well.
Yeah.
Wow.
Yeah, we are hoping to reach 1,000.
Whoa.
You're very ambitious.
So you're only thinking small, huh?
1,000.
Disappointing that you have such small aspirations.
We will work harder next time.
Sure. Yes, exactly. Yes. That's fantastic. That is fantastic.
Yes.
Interestingly, I was talking to, I have a brother who is a tea trader, you know, and he works with Kenyan firms, tea and coffee and so on. And he said that there's a firm which he uses, I can't remember what they're called now, but they are keen to get involved with organizations in the countries And unlike, you know, I don't know if you've ever seen these like Patagonia and so on, it's 1% for the planet, that sort of nonsense. You go, 1%, what's that? This tea company is giving 10% to organizations, 10% of their money. And they've started growing. They're a Canadian company. He lives in Canada. But I said I'd be interested in finding out about whether they'd be willing to do anything. You know, I don't know, absolutely no idea. But there are actually quite a lot of organizations out there, and you just have to know who they are, don't you? You know, it's like, oh, why don't they see us? You know, it's,
Yeah. Oh, please speak to him.
I have started. Maybe
Yes,
nothing
thank
happens. Maybe nothing happens, but it's worth a go, isn't it?
Absolutely. Yes, absolutely. Well, this connection came about because when I go to Nairobi, I stay in Braeburn School, which does a little bed and breakfast, which is very reasonably priced. And a bit of a trade-off is that I've done some coaching, and then I ended up sending a gap student there from Llandovery College. Actually set 2 there who've been doing rugby coaching.
All right.
And a lad who was at Braeburn, who's rugby mad, has decided that Llandovery College there's only one place to go in the UK, which is Llandovery College. And I've sort of taken on guardianship for this lad whilst he's in Llandovery.
Oh, well done.
But it turns out that this guy's in charge of, or is a big fish in, what is it, international
organization, migrants organization,
yeah,
the UN body,
which is a UN body. So this is, it's just an uncanny, it turns out I had no idea that this was the case.
That is too weird. That is too weird.
It's one would think there was a design to this, but we know there isn't.
Yes, we do know there is no design.
We know that,
as a scientist, anyway. Yeah. Right. I'm going to go back and see how they're getting on.
Yeah. Sorry.
No. It's brilliant to hear from you.
Can I just say it's nice to see this has provided an opportunity for far more interaction, hasn't it? And
it's much easier than with 2. Much you.
Isn't it? It's
yeah.
Some of them are out of bed now.
Yeah, I know. Listen, Jerome, obviously the beds just get turned upside down at like whatever o'clock.
9:30.
Right, guys, students. Hello, students. Hello, Fatma. Wake everybody up again. Hello, let's see if we can do this. So, somebody tell me how to turn a propene into propanol. Talk to me. Fatma, give the microphone to some people, or the phone to some people. Fatma, come on, wake up. Hi, students, come on, wake up. I see you've got more students now, Fatma. Well done. Have you been going and throwing them out of bed? Oh, let's have a look. I nearly see that. Hang on.
Propene to propanol, you pass it through steam.
Yes, that's good. Yes, you definitely need steam. Do you know what else you need?
No.
What sort of temperature would we need for steam?
Temperature.
Yes.
I only know the temperature. I think it's you need sulfuric 6 acid.
You can do it that way. Yes, you can do it that way. Yep, go on.
And a pressure of 60 atmosphere.
Yes.
And a temperature of 360 degrees.
Right. If you were doing that, you wouldn't normally use sulfuric acid, but you could. It'd be okay. So very good. That's very good. Now, next one, somebody. So this is around about 300 degrees Celsius. It's 60 atmospheres, and it's an acid catalyst. Very good. Excellent. Next one. Somebody else. So next one is ethene to ethane.
Hydrogenation.
Yes. So how do I do it?
Oh, it is ethene plus hydrogen
Yeah.
to get ethane.
What catalyst?
Nickel catalyst.
Very good. Temperature?
Ni ngapi?
Less.
Temperature.
It's quite low. It's only about 60 or 70. But well
Yeah,
done. Absolutely right. Hydrogen, nickel catalyst, 60 to 70 degrees Celsius. Great. Ethanol to ethanoic acid. Who's
Ethanol to
next?
ethanoic.
Sorry, go on.
Ethanol to ethanoic acid use potassium manganate 4.
And not manganate 4, it's
So it's-
manganate 7. It's KMnO4, but it's called manganate 7. But that's good, yes. And do I have to use anything else?
I only know for
This is
potassium manganate
good. This is good. This is the main thing. There's something else. So we have, sometimes it's written just MnO4 minus, sometimes K without the minus. We need acid. We need a small amount of dilute acid, and we need to warm it. Okay? So we need to warm it up. We need some acid, and we need the potassium manganate 7. The number, it's KMnO4, but manganate 7, right? Ethanol to ethyl ethanoate.
ethanol to
You add ethanoic acid.
Yes. And if I just do that, nothing will happen. I need to add something else as well. It's a small amount of something to get it going. I'll give you a hint. It's a few drops of something. No? Okay, these are the things that matter, these little bits. But you're dead right, really good. It's ethanoic acid. So it's ethanoic acid here, CH3COOH, and it's a few drops of concentrated sulfuric acid. And normally we warm it as well. So the catalyst is a small amount, very, very few drops of concentrated sulfuric acid. Okay, glucose to ethene.
ethanol to
That fermentation.
Yes. So how do I do fermentation?
For methanol. Then the hydration to form ethene.
What do I need to add to it? So let's say I start with cane. Okay, so I cut some cane, I get the sugar out. What do I do to it? What do I add to it?
Sulfuric 6 acid.
Not yet. I could, but I don't normally add acid yet. It's a really simple thing. It's an organism. It's yeast. It's yeast. You know yeast? Don't worry, it's okay. So first, yeast. You were right. It's fermentation.
Yes.
And then, how do I purify it? Because this is very, very raw alcohol. What do I do to it? What do I do to the alcohol when it's just it's mainly water? What do I do? How do I get rid of the water?
Dehydrate.
I could dehydrate, but actually this is on very big scale. This is millions of tons. So it's too expensive to dehydrate. What I do is I fractionally distill. I distill it, okay? Fractional distillation.
fractional distillation.
Yes.
Unaonekana sema fractional distillation.
Fractional distillation.
Sema distillation.
Very good.
Yeah.
Okay. Butanol, butene. Butanol, butene.
Guys are doing very well today.
But they're really great. Really, really good. Yes. I like the way when somebody gets stuck with the phone, somebody has to keep it and they try to pass it on and nobody else wants it. So next one, butanol, butene. Any ideas?
Butanol to butene, you pass it through concentrated sulfuric acid at a temperature of...
You broke up at the end, a temperature of?
180 degrees Celsius.
You are very good at chemistry.
Excellent.
Okay. How do I turn palm oil into soap?
Peroxide to form soap and glycerin.
Sorry, say that again.
You add sodium hydroxide
And
to form soap and glycerin. Condition.
what I'm going to do is I have to do something else. I have to do something else because the sodium hydroxide would work, but it's very slow. So I have to do something else.
Heat.
I think there was one more, but I can't remember it. So we'll just stop there. You've done very, very well, guys. Seriously, that is very good. If you can actually remember each one of these, and it's the little bits like in the making an ester, the few drops of concentrated sulfuric acid. This is really important. Without it, it does not work. Yeah. The glucose, the fermentation, you have to know how to do fermentation. You take the sugar, you add some yeast, and you just warm it for a few days. But then you get very low concentration of alcohol. So then you have to fractionally distill it to fractional distillation to purify it to get to ethanol. Sorry, I forgot what I was doing here. This was to get to ethanol and then to ethene. And somebody said dehydration, which is the concentrated sulfuric acid, the same here. My apologies. I forgot that I had made that one to ethene, okay? My fault. You're clever, I'm stupid, no problem. Okay, so we have to finish. I thought I would show you something at the end. I'm just going to change to another camera. I'll show you what it's going to be. It is just something a bit unusual. We were talking about oxidation of alkanols, okay? You oxidize an alkanol, and when you oxidize an alcohol, you get alkanoic acid. So I'm just going to move over. And but this is a very unusual one. So what I'm going to show you is a very unusual oxidation, okay? It is something that you have seen in nature almost certainly, but I'm going to just show you it now. So I'm changing to the other camera, and here I have some chemicals, one of which is just bleach, just a bleach for cleaning things. And I'm going to take a small amount of this bleach here, right, and I'm going to add some water to it. I'm just going to mix it up now. Into the other conical flask, I'm pouring a chemical called luminol. And I'm going to add the bleach to the luminol, but first I'm just going to turn the lights out. So excuse me, because the light switches are a long way away. Okay, now you can't see anything at the moment. What I'm going to do is I'm going to pour the bleach into the luminol. Here we go. Let's hope it works. It is making light. This is a very unusual reaction. I'm going to add a little bit more luminol to that, and you will see it again a little bit more. This is a very unusual reaction, and it is. I don't know if you've seen, fireflies, and they flash at night. This chemical here, luminol, is a chemical that they use in the back of them, and this is a simple oxidation reaction. And the oxidation reaction, it doesn't produce heat, because otherwise the firefly would fly along and catch fire, which would be quite exciting, but not good for it. So it just gives out light, and it is oxidation reduction, oxidation reduction. We can't do that here. When this chemical is finished, it is finished. Okay, and my lesson is finished. I hear that you are going to be going back to school on Monday. Is that right? Is that correct? Yeah? Okay. Well, I hope it's good. I hope it's okay going back to school and you stay safe and you keep learning, because I must say, from the way you have behaved and learned in the lessons which I have done, I'm really impressed. And I wanted to thank Christine and everybody at St. Jerome for the Happy Teachers Day on Monday. That was really nice. And Christine made a really good speech. She is a very cool speaker. She can stay calm. Most of us go, I don't know what I'm going to say. But she was very good. So well done to her. Now, I must say goodbye, because I have to go and teach my other students. They're not as clever as you, though. Not as clever as you. All right. Okay, so I'm going to say goodbye, guys. I'm going to stop recording, and hopefully you have a good day, and school is okay when you get back. Bye-bye now.
Thank you, Teacher Mark.
It's a pleasure. Bye-bye now.
Thank you.
Pleasure.
Thank you, Teacher Mark.
Thank you.
We are going to miss these guys. We are going to miss St. Jerome. We are going to miss St. Jerome.
See you guys. Take care. All right. Cheers,
So-
Yasin. Bye, Sophia.
Sophia, Madam
Yes,
Sophia.
please. Yes, I'm listening. I'm listening.
I'm reminding you about yesterday.
Okay, okay. I remember the promise. And
What
today,
was-
Yasin is smiling.
Come on.
Yasin is smiling.
Yes.
It's good.
What was yesterday? Come on, you got to tell us.
We promised them a closing lunch for closing ceremony. And Yasin has smiled. Yasin has smiled. So it's good news. There's lunch.
That's a very good memory. Well done. I like that. Is that why people are coming in now?
Yeah, people are coming for lunch.
So forget chemistry. We just want lunch. I don't blame you. Want lunch too. Yasin, you're muted. Yasin, you're muted.
Far too early for lunch.
Ah, yes. These guys should just have.
Far too early for lunch.
It's never too early for lunch.
Take care.
Students,
Bye-bye. Bye-bye.
students, if you want to do some more work, there's that question at the beginning, and Fatma has a copy of this PowerPoint, I think. Anyway, bye-bye.
Yes.
Take care.
Bye-bye.
Bye.
Thank you.
Enjoy
very much.
lunch.
Bye-bye.
Fatma, we will talk.
Yes, indeed. Bye now.
Okay. Right.
Bye, Fatma.